Hi, in this video we're going to look at the situation of three sets of equations with three unknowns and finding a solution to that. Now we've looked at doing this on our graphical calculator, we've looked at doing it algebraically, and we can come up with a solution. What I'm going to look at on this video is what that solution means graphically, visually. So there are three equations over here on the left-hand side that I'd like you to go and key into your calculators now, please. So x minus 4y plus 2z equals 6, 2x plus 3y plus 5z equals 10, 3x plus 7y plus 3z equals 1. Enter those three equations into your calculator and come up with a solution, please. I'll give you a little time in order to do that. So hopefully you've gone and found a solution. You found that there is a unique solution to this. It's not a very nice one in terms of whole numbers. It's got some messy little decimals in there, but that's fine because a lot of the time these results are going to be messy numbers. Don't expect them always to be nice whole numbers. So let's just take a look at what these things look like. So here's the first plane. There's the plane of x minus 4y plus 2z equals 6. Any point that lies on that plane will satisfy those three requirements, that x plus y plus z, x minus 4y plus 2z is going to come up with 6. So we might have a point, for instance, that x is 0, y is minus 1, y is minus 1, and z is 1. And if we go and enter that on and have a look at it, we'll see, yeah, there's a point that lies on the plane, because if I go and substitute those points into that equation, I come up with the number 6. So there's my first plane. I'm just going to hide that point. I don't want it to distract us. The second plane looks something like this. 2x plus 3y plus z equals 10. Now if we move around there, we can see that those two planes intersect along a line. So I'm going to find that line of intersection. In order to do that, I'm going to use this function over here. Click on that, intersecting two surfaces. I click on that surface and this surface, and now we see we've got a line of intersection between those two planes. If I rotate it around there, I can see I've got this line where those two planes cross. Okay, now I'm going to bring the third plane in, and that plane comes in over there. Now it's starting to get a bit messy. We've got these three planes, and they seem to be crisscrossing one another all over the place. So I'm just going to hide the first plane to begin with, and I'm now going to look for the intersection of these two planes. If I just move around, I can see there's the line of intersection of the first two planes, but I haven't got a line of intersection of these two planes. So I'm going to look for that. So here's my first plane, there's my second plane, there's my line of intersection of those two planes. Now I'm going to take out the second plane and reinstate the first plane, because again I don't have a line of intersection for those two planes. They're happening over here, it's happening over here, but there's no line of intersection there. So I'm just going to put that line of intersection in. There's the one plane, there's the second plane. And now it looks as though those three lines are intersecting at a point. If I move them around, we can see that they seem to be crossing over. How do I know if that is actually the case? Well, what I can do, there's a function over here that allows me to find the intersection of two lines. So I'm going to look for the intersection of that line and this line, and they tell me it's this point B over here that has the coordinates minus 1.5, minus 0.44, and minus 2.87. And I'm going to look for the intersection of this line and that line. Oh, it's exactly the same. And then I'm going to look for the intersection of this line and that line, and it's also the same. Now, hopefully that should match up with the results that you get on your calculator. Your results might be slightly different because these have been rounded to 2 decimal places. I think I can go and change that. If I go to settings, will that allow me to change it? Yeah, let's go and take it to 3 decimal places. And let's close that down. And you'll see that we've got 3 points. And hopefully that matches up with the 3 points that you have on your calculator. So what have we got here? What does this mean graphically? Well, what it's telling us is that these 3 planes intersect at one single point. There's one point, that point B, where all 3 planes intersect, cross over at one particular point. And that is why we have a unique solution to those 3 problems, to those 3 equations. There is one point, this point down over here, we're calling it the point B, that will satisfy equation 1, equation 2, and equation 3. If I go and plug those values into those equations, each time I'll come up with, well, for the first equation I'll come up with the answer of 6, the second equation with 10, the third equation with 1. That point satisfies all 3 equations, and that is what we're actually finding when we solve 3 sets of equations for 3 unknowns. Now, hopefully this makes a little bit of sense to you. That solution we've got is the point where 3 planes cross. And that now comes back to the second cases that we looked at, where the graphical calculator gave us a math error. Think about what that is telling us in terms of these 3 planes. Right, we'll talk about this in another video. Goodbye.